So in this lesson we're going to be learning about the y-intercept and gradient and what they are and what they mean. So the y-intercept is the point on the y-axis that is cut by our line. Now we have two axes. We have the y-axis, which runs vertically, and the x-axis, which runs horizontally. So at a point on our y-axis where our line cuts that axis, that's what we call the y-intercept. Now this line here is just a graph of a linear rule, so it's a straight line, and it cuts the y-axis at that point. That's what we call the y-intercept. The x value at that point is 0. So if I was to go along the x-axis, here is when x equals 0, and then that's going up along the y-axis. That shows me the intercept. So the value when x equals 0 is our y-intercept. The form of a linear line, we write it as, you'll remember from previous lessons, y equals mx plus b. Right? In this case, the plus b bit represents our y-intercept. So let's have a look. Here's a graph of the line y equals 2x plus 2. You'll see that the line cuts the y-axis at positive 2, and in our equation you'll see the plus 2 bit represents the y-intercept. We can check that by also putting the x value as 0. So we'll write out our rule, y equals 2x plus 2. When x equals 0, we can substitute the x for 0, and we get 2 times 0 equals 0. So we have 0 plus 2 equals 2, and once again that is correct as it lines up with what we've seen on our graph plus what we have in our linear rule. Let's do another one. Here is the line y equals half x take 2. You'll see that the take 2 part of our linear equation also aligns with the fact that it cuts through negative 2, but let's also use some substitution. We'll substitute when x equals 0. We get half times a 0 is 0. 0 take 2 leaves us with a negative 2, which is correct. One more. This time we've got a line sloping up to the left. So we know, we should know, or we're going to learn shortly as well, that means it has a negative gradient. So our linear equation here is y equals negative 2x plus 2. So our y-intercept portion is the positive 2. Once again, that looks correct. That's where our line cuts through. Let's have a look using substitution. We're going to substitute when x equals 0. We get negative 2 times 0, which is 0, plus the 2, which leaves us with a y-intercept of 2. Moving on now to the gradient. The gradient is just a measure of how steep a line is. Lines that slope up and to the right have a positive gradient, and like the one we saw in the last example, lines that slope up to the left have a negative gradient. The linear form of a line is y equals mx plus b, and the m in front of the x here represents our gradient. So we say that the slope of the line, or the gradient, we usually represent with the letter m. Here's a equation y equals 2x plus 3. If I was to look at that, I can see that the number in front of the x, because it's written in the form y equals something, the number in front of the x is our gradient. In this case, m equals 2. In this case, we've got y equals 4x minus 7. The gradient of our line, m, would equal 4. This one, y equals negative 6x plus 2. The gradient, the number in front of the x, because we've got y equals something, is negative 6. In this one, we've got a quarter x. Now, they don't have to be whole numbers, so in this case, m, the slope of our line, would be 1/4. Now this one's a little trickier. We're going to have a bit of a look and work on this one. 3 plus 2y equals 4x. Now I know it's a linear equation because there's no x squareds or x cubes or anything like that. The highest order of x is 1. That means it's going to be a straight line, but it doesn't have the form y equals something. So I'm going to have to modify this one a little bit to make it look right before I can decide what m will be. Using our algebraic skills, the first thing I want to do is get the 3 over to the other side because my goal is to get y on its own. So we'll take the 3, get rid of it and put it over here. We do that by taking away 3 from both sides. You'll see that 3 and negative 3 cancel each other out because 3 minus 3 equals 0. That way I end up with 2y equals 4x minus 3. Now I'm nearly there because my goal is to get y on its own. I've got 2y, so to get y on its own I need to divide both sides by 2. Remember, whatever I do to an equation, I can do whatever I want as long as I do the same to both sides. So I'm going to divide both sides by 2. This allows my 2's, 2y over 2, the 2's cancel out, so I'm left with y on its own. So y equals 2x, and the reason the 2x is that the 4x over 2, that simplifies down to 2x. Take 3 over 2. Now it is in the form y equals mx plus b. Y equals something x and a constant for our y-intercept. So in this case, m, the slope of the line, would be 2, and our y-intercept would be at negative 3 over 2. The other way we can work out the gradient, we say that the gradient of a line equals rise over run. So m equals rise over run. Let's have a look at those two terms, rise and run, and see what we mean. Here's our line, y equals 2x plus 1. We know the y-intercept is at positive 1. We know the slope of the line, the gradient, is 2. If I take 2 points, any 2 points on that line, in this case I've taken the point 0, 1, which is the y-intercept, and the point 2, 5 up here. I can draw a right-angled triangle by taking lines that run down from the top point and across this point, and at this point they join and make a right-angled triangle. Using that triangle, the vertical distance here of that triangle is what we call the rise. In this case that is 4 units, so I go from 1, 2, 3, 4 units in length, and the run is the horizontal distance of my right-angled triangle. In this case it's 2 units because I start here, I go 1, 2 units. According to our little equation here, m equals rise over run. In this case 4 is our rise, 2 is our run, so we have 4 divided by 2, which equals 2, which is great because that certainly agrees with what we've got up here in our equation, that m equals 2. Doesn't matter which 2 points I take, I'm working on the same line. I've kept this same point 2, 5, but you'll see from further down the line, instead of using 1, 1, I've used negative 1, 1, which is also on the same line. Now the line hasn't changed, so the gradient should be the same no matter which 2 points I use. Let's test this one. The rise in this case is 6 units. 1, 2, 3, 4, 5, 6. And the run is 3 units. From negative 1 I go 1, 2, 3 units. Gradient equals rise divided by run. In this case 6 divided by 3 equals 2, which gives us exactly the same gradient. So let's look at another example. This time we've got a linear graph here that has a negative gradient because it slopes up to the left. And the equation of this line is negative 1/3 x plus 1. Take any 2 points. I've chosen the points negative 3, 2 and 6, negative 1. We'll draw out our vertical and horizontal lines to make a right angle triangle. And we'll measure our rise and our run. The rise in this instance is 3 units, and the run is 9 units in distance, but it's actually -9 because starting from my line, my triangle goes out to the left, which means it moves out in the negative direction along the y-axis. It's very important that we remember that difference. It's actually a -9 because it's moving towards the negative numbers. Let's plug those into our rise over run. We get 3 divided by -9, which simplifies down to -1/3, and you can see that that is the same value we had in our equation for m of -1/3.